A simple check of a single notification often spirals into a 30-minute loop. Your thumb moves autonomously, pulling up a continuous stream of videos and posts long after the novelty has faded. By the end of the loop, most users report they are no longer laughing, learning, or subjectively enjoying the experience. The physical motor action of scrolling continues, despite a lack of conscious satisfaction. This behavior is driven by the mesolimbic dopamine system. While often associated with pleasure, dopamine actually functions as the brain's currency of motivation, anticipation, and learning. Its primary role is to assign importance to a stimulus and trigger the motor urge to obtain it. We are left with a conflict between our physical drive and subjective experience, a robust urge to continue an action we no longer enjoy. The human brain relies on two anatomically and neurochemically distinct systems to process rewards. While they normally work in tandem, they can be uncoupled. The first system, liking, produces the actual sensory pleasure derived from a reward. It is mediated by small, fragile hedonic hotspots. The wanting system is a much larger, robust network projecting to the nucleus accumbens, utilizing dopamine to drive the organism toward a goal. This chart shows a physiological dissociation. As the red wanting line ascends, the blue liking line declines. Their intersection marks where motivation becomes sensitized. At the far right is phantom seeking. The urge to obtain the reward is maximized, even though pleasure has decayed. Compulsive scrolling occurs because the dopamine-driven anticipation system has effectively bypassed the neural circuits responsible for our enjoyment. This bypass is achieved through the computational timing of dopamine release at the synaptic level. This illustrates reward prediction error. Dopamine fires based on the difference between expectation and reality. A better-than-expected reward generates a positive error, triggering a spike. When fully expected, the error is zero, and dopamine remains at baseline. Without surprise, the brain stops assigning motivational value. Slot machines prevent this baseline, using variable ratio reinforcement schedules. Because the reward's timing and magnitude are unpredictable, the brain cannot form an accurate expectation. Digital environments integrated this mechanic into the infinite scroll. Notifications and content delivery operate on the same probabilistic schedule as the mechanical lever. Because content is delivered randomly, the brain's expectation never catches up. This mismatch ensures the reward prediction error never resolves to zero. Algorithms maintain the dopaminergic seeking loop by ensuring the brain is always kept guessing, driving the motor system to engage with relentless vigor, even when the subjective yield is minimal. Clinically, there is a distinction between the functional shifts of problematic smartphone use and the structural changes seen in recognized substance use disorders. Popular descriptions of dopamine depletion are inaccurate. The brain doesn't run out of dopamine from checking notifications. True depletion is a symptom of neurodegenerative disease. Chronic substance abuse is associated with a verified downregulation of dopamine D2 receptors. While severe gaming disorder adaptations, standard social media lacks evidence of similar receptor destruction. Digital compulsion is characterized by a functional network shift rather than structural damage. Control of the behavior migrates between different regions of the reward system. This is the ventral to dorsal striatal shift. Digital engagement begins in the ventral striatum, which evaluates stimulus value. Over time, control moves to the dorsal striatum, which mediates automated motor responses. Digital compulsion represents a functional reconfiguration where a repeated action has been handed over to the brain's habit-driven autopilot. Addressing this behavior requires us to acknowledge that the digital brain is functionally misaligned rather than permanently broken. Because the underlying chemistry is intact, trendy concepts like a dopamine fast to reset the brain are scientifically invalid. Taking a break from screens is a behavioral intervention, not a physiological detox. Restoring balance requires re-engaging the prefrontal cortex to exert top-down inhibitory control over the habitual drives of the dorsal striatum. Removing environmental triggers, such as variable notifications, strips digital cues of their incentive salience. This allows the wanting and liking systems to eventually recouple as the brain stops being prompted to anticipate a reward. Managing these habits involves removing the unpredictable cues that trigger the urge to anticipate a reward that will never arrive.